Guys, in this video, we're going to talk about the transformation, the X-shift factor. In the two previous videos, we talked about Y-stretch factor and a Y-shift factor. In this case, we're going to talk about the last of the three transformations for quadratics, the X-shift factor. So I have the X values and the Y values for the base graph Y equals X squared here. I also have the graph plotted out here for you, ready to go. So I'm going to do a transformation where I'm taking these X values and I'm going to reduce them by 1. So that's the goal here in this column as I generate the numbers. So I'm going to take the X values, substitute them in, and after I substitute it, I'm going to reduce this by 1. See what happens to these numbers. So we have the X value is -3, take away 1 squared, and -3 take away 1 is -4, and that'll be 16. -2, take away 1, that is -3, and that's a 9. -1, take away -1 squared, that's a 4. 0, take away 1 squared is 1. 1 take away 1 squared is 0. And clearing this. 2 take away 1 squared is 1, and 3 take away 1 squared is 4. Okay, so let's go back here and then plot it on the grid to see what this transformation looks like. So the first point is -3, 16. We cannot plot that. Okay, there's no space here, there's no 16. So -2, 9. Okay, so we go -2, 9. -1, 4. -1, 4. 1, 0. 1, 0. 0, 1. 1, 0, 1, and then 1, 0, 2, 1, and 3, 4. So 3, 4. So I join these points. Okay, let's blow this up to get more detail. So here we are. So now we don't get a full parabola, but we have another point here. Okay, so we can extend this point all the way to the other side and complete it. But how do we know how much to extend? You know from before that there is a axis of symmetry that is going through the one. So this is the location of the axis of symmetry. Now the point here is 3 units away. 1, 2, 3. Go to the other side 3 units away because of symmetry. 1, 2, 3. So I have another point there. So I can extend my graph and make it look nice. Okay, so now even though I didn't generate this point from the table of values, I can generate it from the graph. So let's make some observation here. So the vertex has moved right by 1 unit. This point here, 1, 1, has moved right by 1 unit. 2, 4 moved right by 1 unit. And originally we had 3, 9. Okay, so 3, 9. So here, this is not the point. I made a mistake there. So let's correct it. And then originally we had a 3, 9 and 3, 9. And that also has moved by 1 unit. So the whole parabola, you can check it on the left side as well. The whole parabola has moved to the right by 1 unit. Take a look at the equation. X minus 1. So when we take a 1 away from the x within the bracket, when we subtract, the graph moves to the right. Okay, so let's make a prediction here. It is a addition of 2. If the subtraction makes the graph move to the right, what do you think will happen if we add a 2 to the left? What kind of a transformation will happen? Just think about it for a second. In the meantime, let's plug in these numbers and see what happens. So here we have -3 plus 2 squared is a 1. -2 plus 2 squared, 0. -1 plus 2 squared, that is a 1. Put a 0 here. 0 plus 2 squared equals 4. 1 plus 2 squared equals 9. And there's 2 plus 2 squared equals 16. Now, obviously, we cannot plot the 16 or the next point that's going to be bigger than 16 on the graph. So I'm going to stop here. I'm going to put all these points into the graph and see what happens. So what do we have? -3, 1. Okay, so we have -3, 1 right there. -2, 0 right there on the axis. -1, -1. I'm sorry, guys. I need to go back again. I forgot to shift it by 1. So let me clear that. Not a big mistake here. Let's clear that and start again. -3, 1. So -3 is right here. -3, 1. -2, 0. And then we have -1, 1. Okay, we have that. And then we have 0, 0, comma 4. So 0, comma 4, 1, comma 9. 1, comma 9. Okay, so let's join this. Okay, we notice that we don't have a full parabola, but we can get it done. So let's zoom in here. And so what do we know? We know the axis of symmetry is here, right here, x equals -2. So we can take the points from one side and reflect it to the other side to get the other points. So take this point, 0, 4, that is 2 units away from the axis of symmetry. So the other point is on the other side there. And then this point here, 1, 9, it is 1, 2, 3 units on the other side, go 3 units this way. So now using this idea of axis of symmetry, I can get all the points I want. Terribly sorry, that's a bad graph. Okay, so let me correct it the best I can. Okay, here we go. Okay, so let's make some observations here. What do we know? The graph in black is the base graph. And what do we have here? X plus 2. Many of you would have already guessed it's a plus 2. And what you see is the blue, the whole graph, that is the black, has shifted to the right by, to the left by 2 units. See that? That shift everywhere by 2 units. It's the same thing on the other side. I'm not drawing arrows because it can get very crowded, the picture. So what do we conclude by looking at this? So let's make some notes here. If you have an equation that looks like y equal to x plus h squared, okay, now the h is going to make it move left or right. Now the previous case we saw, the y transformation, the value looked like this: y equals x squared plus k. The k was outside the square. Here you notice here the h value is within the bracket and it is being squared. This means that this is a x transformation. So when you add the h value if it is less than 0, say for example in this case the h value here in this case is a -1, it is less than 0, then we shift to the right. Okay, the eraser. Okay, oh yeah, it's not responding. Okay, here we are. It is shifting to the right. Shift right. Shift right by h units. If the h value is bigger than 0, you're going to shift left by h units. I'm sorry about the interruption of a few seconds there in the middle of the video towards the end, but I didn't want to stop because we have talked so much about it. Please fast forward as and when you need to skip those parts. But this is the lesson, and see you guys in the next video.